Now, one of the things that we'll notice using this method for doing division is that it's very sensitive to everything that appears along a diagonal being a like term. And this is problematic if we want to do, for example, the division x to the fifth plus 2x to the fourth minus 16x minus 32 divided by x squared minus 4. If we set this up kind of naively, we'll write x squared minus 4 on the left. We'll need an x to the fifth here, which means we'll start with an x cubed term, have an x squared term, an x term, a constant, and maybe a remainder. What's the problem here? Well, notice that when I do these multiplications, right, here I have x cubed times, of course I'm going to need a 1x cubed here. I'll have x cubed times negative 4 for a negative 4x cubed. But up here, I'm going to be writing some sort of an x to the fourth term, because I'll have x squared times x squared. This violates our expectation that we'll have like terms down the diagonals. How can we get around this? Well, notice the problem here is that my divisor is missing an x term. I can put one in. Instead of x squared minus 4, I can write this as x squared plus 0x minus 4. And then, instead of setting up this box, I'll set up a box with x squared, 0x, and minus 4. I'll still want the same columns, but I think this actually solves my problem, because now I'll have x squared times x squared, x cubed times x times x squared times x, constant times x cubed. Here I'll have x to the fourth terms along the diagonal, here x cubed, here x squared, here x, and here constant. Now this row is going to be particularly boring. It's always going to come from multiplying by 0x, so it's really always going to be 0. But it's going to keep my organization going. All right, with that in mind, let's do this division. Here I've got an x to the fifth. Right, just x to the fifth. So that'll be 1x cubed times x squared. Right, when I do this multiplication, I'll get 0. X cubed times negative 4, that's negative 4x cubed. To figure out what goes here, well, these are my x to the fourths, remember. I need my total coefficient to be 2. So I'll say 0 plus what gives me 2. Well, that's especially easy. This must be 2x to the fourth. X squared times what gives me 2x to the fourth? It must be positive 2x squared. Again, 2x squared times 0x gives me 0. 2x squared times negative 4 gives me negative 8x squared. X cubed, I don't see an x cubed, do I? There's no x cubed term here. What does that mean? Well, that means I have 0x cubed. My total coefficient along this x cubed diagonal has to be 0. Minus 4 plus what will give me 0? Well, what is 0 plus 4? It must be 4. I must have 4x cubed here. X squared times what will give me 4x cubed? It must be 4x. 4x times 0x, still 0. 4x times negative 4, negative 16x. Here's my x squared diagonal. Oh, I don't see an x squared term here either. Must be 0x squared. So my total coefficient here has to be 0. Negative 8 plus what gives me 0? Well, it's going to have to be positive 8. So I'll have 8x squared here. X squared times what gives me 8x squared? Gotta be positive 8. 8 times 0x gives me 0. 8 times negative 4 gives me negative 32. All right, for my x term, I need negative 16. Already got it, so this is 0x. And for my constant, I need negative 32. Already got it, so this is 0 again. So what do we do when we're missing terms? When we're missing terms, we just fill them in with zeros. If we're missing terms in our divisor, we put in a row for 0. And the reason we do that is just to keep the diagonals neat. If we're missing terms in our dividend, well, they're 0 when we come to them.